Chapter 17, Fossil Fuels, Energy and Impacts. This chapter is about the three fossil fuels, coal, oil, and natural gas. The central case is about the oil on Alaska's North Slope. Sometimes we call this oil from ANWR, the Arctic National Wildlife Refuge. And on the next page, we do have some sticky notes regarding ANWR. So ANWR, again, is the Arctic National Wildlife Refuge, and most of this land is preserved already. What is open to drilling, possibly if Congress opens it up, is what's called the 1002 area. So if you look on this map here, you'll see that we already drill up here at the top of Alaska. This is, again, the very, very top of Alaska right here. We already drill in this area here, the National Petroleum Reserve. And then in green, we have the National Arctic Wildlife Refuge set aside, which we call ANWR. And what Congress did way back several years ago when they created this wildlife refuge was they have the option here of possibly voting to drill in the 1002 area someday. The rest of it is, see this mountain range here? The rest of this is very difficult to get to, and it would be difficult to cover this mountain pass to drill the oil here. But they left this part that is more accessible as, you know, perhaps someday we could drill it if we open it up to drilling. And that is the part that is comes before Congress every couple of years to open that part up. So what you need to know is the ANWR is, again, the Arctic National Wildlife Refuge, and most is preserved permanently, but the 1002 area can be opened up to drilling if Congress votes to allow it. About every year or two in Congress, it's written into some sort of a law to, some sort of bill to open it up, and at this point in time, it's been voted down many, many, many times. So pro-drilling people say it's important to open this up because of jobs, money, economic development, and to reduce the reliance on foreign oil. Anti-drilling advocates, they say that the ANWR area is essential habitat for your migrating caribou, your birds, and other native species. The Gwich'in, which is the Native Americans that live up there, rely on caribou, which use that area to graze. It's part of their culture and their food supply. It's one of the few remaining wild places in the world, and it would not significantly drop gasoline prices, maybe a penny or two per gallon, which is an estimate, and would not really help our dependence on foreign oil very much at all. All right, down here at the bottom of page 559. So we have different sources of energy here: crude oil, natural gas, coal, nuclear energy, biomass, hydropower, solar energy, wind energy, geothermal, and tidal and waves. Most of this is derived from the sun, directly or indirectly, and let me explain. Fossil fuels came originally from fossils, which used to be living things. And living things, if you're a plant, your energy came from the sun. If you're an animal, well, you ate plants, which energy came from the sun. So even to this day as humans, we eat things, our energy comes really from the sun because we eat plants, or we eat animals that eat plants, and it comes from the sun. Solar obviously comes from the sun. But wind does as well, because if you remember how winds are formed, you have convection cells, which is hot air rises because the sun is heating the air, cool air falls, and then the Coriolis effect creates the wind. So the warm air rising is really coming from the sun. Hydrothermal, you have the water cycle, you have evaporation and then precipitation and then runoff into rivers, and then we dam those rivers and we get hydrothermal power. Biomass is basically burning living things like trees where we burn wood, or even corn where we turn it into ethanol, and again, that's from photosynthesis. Waves also are powered by the wind. So winds create waves, and that wind came from convection currents, which came from solar energy. There are a few exceptions, and that is like uranium is not from the sun. Also, geothermal is not from the sun as well. All right, the next page, page 560, talks about the history of oil. You don't really need to know this, but on page 561, you need to know what a fossil fuel is. It's organic material broken down in anaerobic conditions, and heat and pressure and time create these fossil fuels. And again, this is page 561 right here, and at the top we show our consumption of certain fossil fuels over time. Page 562, slide over to 562. So this is how coal and oil were formed. Make sure you know the figure in the caption here. So with coal, we have ancient swamps that were buried, and over time, heat, pressure, and time turns it into coal. Oil used to be basically plankton in the ocean that died, were buried by sediments, and heat and pressure over time turns them into oil. A lot of oil is still under the ocean. Some of it is not, but it was places where there were oceans at one point in time. So again, make sure you know that coal is ancient forests and oil is ancient plankton. Turning the page to 564. Oh, well, first on this page, we have oil consumption in the world. You can see that, energy, not just oil, but energy. Energy consumption in the U.S. is first. Then there's some other countries that use a lot of energy as well. Saudi Arabia uses a lot of energy because they have a lot of cheap oil. Iceland uses it because they have free geothermal. They're on volcanoes. They get geothermal energy. All right, next page, 564, coal. Now, you need to know the caption, you need to know this picture here, and the different types of coal. So when a forest dies and decomposes, the first thing that it turns into is peat, P-E-A-T. This is not quite coal yet. It's a precursor to coal. In Great Britain, they use it to heat and cook with, not as much energy stored in it as coal. And then once you have a little more heat and pressure and time, it turns into lignite, and then more is bituminous, and then anthracite. Anthracite is the purest coal, it's the cleanest burning, and it has the most energy stored per piece of coal, per volume of coal. And we have that here about peat being a precursor, and anthracite is the best coal there is. On page 565, we also have mining, and we studied mining already. We combined it with chapter 14, and so you have already seen that there's different types of mining. This is mining for coal. This is underground mining. We call it subsurface mining, and then we have strip mining here. This is the least environmentally harmful, and this is the most environmentally harmful. But this is the most dangerous for workers and the least dangerous for workers. Turn to 565. On 565, we show how electricity is generated from coal, but you could also replace this with natural gas or oil or even uranium. Okay, so what happens is coal gets pulverized in a mill, and then we light this coal on fire, and above that we have water. The water boils in these little tubes, and because the tubes are small and there's water in here, it turns into steam, but because we feed the steam through small tubes, it has a high amount of pressure and bursts out really, really fast, like a tea kettle does. That pressure from the steam spins turbines, which create electric spark in a generator, and those electric sparks go to your house, and that's what electricity, it's electrons, it's electric sparks. Well, this water has to be cooled, and so you have cooling towers. And then you have leftover coal here, which the ash has to be disposed of, and then the smoke is in smokestacks. And so when we burn coal, what comes out of our smokestacks, we've already learned, is sulfur dioxide, which is an air pollutant, and it causes acid rain, carbon monoxide, and particulate matter. We can put on our smokestacks wet scrubbers for sulfur dioxide. We could put on electrostatic precipitators for particulate matter. And what is also released is carbon dioxide, which causes global warming. So here's our stages, and yes, you have to know the stages. So first, a fuel such as coal. In California, we actually burn natural gas, but we do the same thing, except it's natural gas. It burns cleaner though. And then the heat causes water to boil. Steam is forced through pipes, which create pressure to spin turbines, which cause electrons to move in generators. Electrons, which is electricity, is sent to the public through wires. So here's some clean coal technology to try and clean up this coal. Remember, half of our coal in the U.S. is from burning, half of our electricity in the U.S. is from burning coal. So we've talked about these things already: scrubbers, electrostatic precipitators. Gasification of coal is one option, and carbon dioxide capture and depositing underground is another idea to try and clean up coal. All right, on page 568, you need to know the top producer of oil and the top consumer. So Saudi Arabia produces the most, and the United States uses the most oil. So now we're on to oil. This is no longer coal. We are talking about oil, crude oil or petroleum oil. Same thing. How do we search for fossil fuels in general? We drill rock cores. We do seismic surveys. So make sure you know these pictures here about how we search for oil, coal, natural gas. How do we drill in the ocean? Well, you have these pictures here about how we extract the oil from the ocean. Some places are pretty shallow, like off the coast of California. We have these oil platforms out there, and it's not very deep. But the big disaster, the BP Deepwater Horizon that we learned about in Chapter 16, was pretty deep. It was over a mile deep, and that is before you hit the floor of the ocean, and then you had to dig into the oil deposit. And because it was a mile deep underwater, we couldn't send down a diver to plug the leak. We had to send down robots, which didn't work. We couldn't plug it. And so they had to drill an additional well to the side to relieve the pressure here, because once you drill into this pocket of oil, so much pressure is released that it will spurt out, and there was a break right here where the oil leaked into the ocean. And so they had to drill another well to hit the oil, relieve the pressure in the first one, and when the pressure was released because they were pumping oil out of that one, they could fix the hole in here, and that's how they eventually stopped the leak, but it took over a month to do that. So make sure you know the pictures and captions of how we get oil from the ocean. On page 570, petroleum is used in a lot of products. You can see that. Just make sure you understand a few of those and be able to know a few of those.